Example 4. Find a quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. Okay. In the question, they have given sum of its zeros as -3 and product of its zeros as 2, and they want to find us what is the required quadratic polynomial. Okay. Now, let us assume that alpha and beta are the general zeros for any quadratic polynomial ax squared plus bx plus c. So they given alpha plus beta, which is equal to minus b by a, which is equal to -3, and alpha beta, which is equal to c by a, which is equal to 2. Then we can clearly see that by these two, the value of a as 1 and value of b is equal to 3 and value of c is equal to 2. So by knowing a, b, c and values, we can easily frame the required equation as x squared plus 3x plus 2. Okay. There is also another method to find the general equation when alpha and beta are given. The general equation is x squared minus alpha plus beta into x plus alpha beta is equal to 0. So this is one of the general equation to finding the required polynomial equation when alpha and beta are given. So if we substitute minus of alpha plus beta value, that is minus plus 3 and alpha beta is 2. So we are getting again the same x squared plus 3x plus 2. Okay. Now let us see for cubic polynomials what are the zeros and how is the relation established between their zeros and their coefficients. Okay. Let us consider a cubic polynomial, that is p of x is equal to 2x cubed minus 5x squared minus 14x plus 8. Why I am calling this as a cubic polynomial? Because the degree of the equation is 3. Okay. Now let us assume that the zeros for the given p of x are x is equal to 4, minus 2 and 3. We know that for the degree of 3 we are having at most 3 zeros. So I am considering 4, minus 2 and 1 by 2 are the 3 zeros for the given cubic polynomial. Okay. Now we know that the sum of the zeros, that is alpha plus beta plus gamma, which is equal to 4 plus minus 2 plus 1 by 2, the resultant is minus 5 by 2, and we know that it is equal to minus coefficient of x squared by coefficient of x cube. In the given question, the coefficient of x squared is minus 5 and the coefficient of x cube is 2, hence minus of minus 5 by 2, which is equal to 5 by 2. Okay. And the product of its zeros, which is equal to 4 into minus 2 into minus 1 by 2, which is equal to minus 4, which is equal to the constant term divided by coefficient of x squared, that is 8 divided by 2, which is equal to minus 4. Okay. Now in addition to this, for cubic polynomial there is one more term, that is the sum of product of its zeros, that is the sum of product of two zeros at a time, which is equal to 4 into minus 2 plus minus 2 into 1 by 2 plus 1 into 4 by 2. Okay. Now we are getting 7, so which is equal to coefficient of x divided by coefficient of x cube. So here it is considered as minus b by a, and here it is considered as minus d by a, and here it is considered as c by a. Okay. Now in general, it can be proved that alpha, beta, gamma are the zeros of a cubic polynomial ax cube plus bx squared plus cx plus d. Then sum of its zeros alpha plus beta plus gamma, which is equal to minus b by a, and sum of product of two zeros at a time, that is alpha beta plus beta gamma plus gamma alpha, which is equal to c by a, and product of its zeros alpha beta gamma, which is equal to minus d by a. So example 5, verify that 3 minus 1 and minus 1 by 3 are the zeros of a cubic polynomial p of x, which is equal to 3x cube minus 5x squared minus 11x minus 3, and then verify the relationship between zeros and the coefficients. Okay. So in the question, what they are saying, they have given one cubic polynomial p of x, and they were asking, they are given 3 zeros and they want to verify that these three values of x are zeros or not, and also see the relationship between the zeros and coefficients. Okay, to check whether the given values of the equations are zeros or not, we have to substitute the given value individually in the place of x, and we have to see the result. Whether if the result becomes 0, then we can say that the value or the 0 of a given polynomial, and if the result is not 0, then we can say that the given value is not 0 of the given cubic polynomial. Okay, let us see. So given polynomial, when we compare with the given polynomial, we are obtaining the value of a is equal to 3, value of b is equal to -5, and value of c is equal to -11. Okay, now we have to verify whether the given numbers are zeros or not. So I am finding p of 3, that is I am replacing x with the 3, so I am getting the value of 0. Okay, now I am finding p of -1, so again I am getting the value 0. Now p of -1 by 3, again I am getting the value 0. So these 3 points, when I substitute in terms of x, I am getting the value 0, as these 3 values are considered as zeros of the cubic polynomial 3x cubed minus 5x squared minus 11x minus 3. Okay, now if I want to check the relationship between zeros and coefficients, I know that the sum of the zeros alpha plus beta plus gamma, which is equal to minus b by a. So in the question, when I compare with the standard form, I am getting minus b by a as 5 by 3, and if I find sum of product of its two zeros at a time, that is alpha beta plus beta gamma plus gamma alpha, which is equal to c by a, that is c is minus 11 and a is 3, so I am getting minus 11 by 3. Okay, if I find product of its zeros alpha beta gamma, which is equal to minus d by a, so minus d by a means minus of minus 3, that is plus 3 by 3, which is equal to 1. Hence, these three relationships between the zeros and coefficients are verified